So we already seen that Ohm's law and field theory, that is J is equal to sigma into E, where sigma is the conductivity. So this conductivity is temperature dependent. Now, if you observe the plot between E and J, this is the straight line passing through the origin, and slope of this line will give the conductivity. The reciprocal of conductivity is called resistivity. That is this. Now we know this J is current density given by the formula current per unit area, and E is given as spread voltage per unit length. If you substitute these formulas in this, then I will get I by A is equal to sigma into V by L. So I is equal to A into sigma L into V. Here, for a given material, the area of cross section of the conductor is constant, and conductivity is also constant, and length of the conductor is also constant. Now, this I can write as V by R, where R is equal to L by A into sigma. And we know that 1 by sigma is equal to rho, that is rho L by A, that is R. Here R is called resistance of the conductor. So my resistance of the conductor is proportional to the length of the conductor, and it is inversely proportional to the area of the conductor. And rho is the resistivity. This is the material property, and it is varies from material to material, and this resistivity is also depend upon temperature, because this resistivity is depend upon conductivity, and this conductivity is depend upon temperature. So my resistivity is also depend upon conductivity. So this is conductivity is also depend upon temperature. So how it is depend upon temperature, we will see later. Now this equation I can write here, I is equal to V by R, which means current through the conductor is proportional to the applied voltage, and the proportionality constant is 1 by R. This 1 by R is called conductance. And this I is proportional to V is called Ohm's law. Ohm's law in circuit theory. So there are certain limitations on this Ohm's law. My current is proportional to V as long as my R is maintained constant. To maintain R constant, I need to keep temperature constant. What happens if the temperature is not maintained constant? Let us consider conductor again. Now, here free electrons are like this. Consider Ag plus, means one free electron. Silver conductor having one free electron like this. As my temperature is increasing, Now what happened? This electron movement will increases, and because the temperature increases and because the movement is increases, the number of collisions occurred inside the conductor collisions occurred in the conductor increases. So as my electrons are colliding with the neighboring electrons, what happen? They will lose the kinetic energy. So once they lose the kinetic energy, the drift velocity of the electrons will decreases. When the drift velocity is decreases, the amount of charge carriers crossing this cross section area will decreases, which means my current decreases. So in a conductors, when temperature is increases, my collisions are increases, thereby conductivity nature is decreases, and the losing of kinetic energy will be releases in the form of heat. So because of this reason, in any conductors or resistive elements, heat will liberated from the conductor as my current is flowing in the conductors. Now what happen if I use the copper 2 plus and aluminum 3 plus? If you see that copper is having 2 electrons free and 3 electrons are free here. So in my previous video I said among these two materials, copper and aluminum, my silver is having high conductivity because of the same reason. So here the number of electrons initially having more, and the number of collisions also will be the more when compared to the silver, which means we can conclude that if the number of electrons in the conductor is increases, this also will leads to the increase in number of collisions among the electrons, thereby drift velocity will decreases, thereby current conductivity decreases. And because of that reason, among copper, aluminum, silver, my silver is having high conductivity. So summary point, in order to have high conductivity, there should not be less number of electrons and there should not be a more number of free electrons, which means number of collisions among the electrons should be low to make conductivity high, so that my current will increases for a given applied voltage. Now draw the I and V characteristics from this equation. This is V and this is I. Now this is the straight line passing through the origin, and slope of this line is gives the 1 by r, and this is the characteristics of your Ohm's law. Now limitations are given here. Ohm's law does not apply for non-metallic conductors because these non-metallic conductors having the property of non-linear. So the relation here between I and V will become non-linear nature. So it may be like this, somewhat, or somewhat like this. So when the input voltage and current is not proportionally changes, then this is a non-linear material. For the non-linear material, where Ohm's law is not valid, and it is defined at a constant temperature. So temperature should be maintained constant, otherwise, so what I said now, those things will be occurred so that my current will changes for a given same voltage. Now this theory, I is proportional to V theory, is applied up to a frequency of 1 megahertz. After this frequency, my resistance is again changes. depend upon the frequency, so that my I will change for a given applied voltage V. So again my Ohm's law will not valid. So for higher order frequencies, I need to consider a field theory Ohm's law, that is J is equal to sigma into E. In certain cases in the circuit theory, there is some element like this and it is carrying a current I, then definitely there is a drop appeared across this element called V. Again, this V drop across the element is proportional to the current, how much is passing through the element. So this is we can get from this circuit theory Ohm's law. So here from this I can write V is equal to I into R. What it means? Voltage across any element is proportional to the amount of current passing through that element, and proportionality constant is R, called resistance of that material. So my VI characteristics will become like this: V into I, and the characteristics is a straight line passing through the origin, and slope of this line is resistance. So here the summary point: my V is proportional to I means where V is the drop across the element. So this is the drop appeared across the element. I is proportional to V means where V is the potential applied, that is source.